We've been talking about stars being these big, giant nuclear reactors. And so here we have a very simplified model of the sun. And this is pretty straightforward and pretty similar to all stars. So any star that you see will have a pretty general shape as the same way. Now, at the very center, it's the core. And this is where the fusion reactions are taking place. Remember, the fusion is producing helium and neutrons, but is also giving off a tremendous amount of energy. And it is this energy that we're really concerned with today. The energy is released as a gamma photon. Okay, great. What does that mean? Well, gamma refers to the type of electromagnetic radiation, and that has the shortest wavelength but the highest energy. And a photon is a particle of light. Now, to kind of think about how much energy this actually is, every second, the sun converts 500 million metric tons of hydrogen to helium. That is a lot of energy. Remember when we did our stair lab and we found that, our power output was somewhere around 1,000 watts for most of us when we ran up those stairs? The sun is giving off 384.6 times 10 to the 26th watts. And it's just an incomprehensible amount of energy. So you can also think of that as being about 9 times 10 to the 10th megatons of TNT per second. So now we have all of these gamma photons being released into the core of the sun. So it's getting more and more crowded in there. Have you ever been in a really crowded room and decided that you wanted to get to the door? It's not always that easy. The same thing happens in the center of the sun. As a photon is released, it starts moving. These photons of energy are emitted, absorbed, and then emitted again by various particles in the middle section of the sun called the radiation zone. There are a lot of other photons in there, so there are a lot of collisions. So these photons bounce around and bounce around and bounce around for a very long time. This is what is known as the random walk, a pretty descriptive term to describe the motion of the photon as it collides with its surroundings before making its way to the edge of the radiative zone. So instead of going in a straight beam of light, they travel in a zigzag direction, eventually reaching the surface of the sun. In fact, it can take a single photon up around 200,000 years to make the journey through the radiative zone of the sun. So you have this particular diagram on your worksheet. So find this random walk activity on your page. You're going to So you have this diagram on your worksheet. So find this spot down there. And what we're going to do is we're going to roll some dice to simulate this random walk through the radiative zone. So this diagram here represents the sun. The center dot here in the middle represents the core where the photon is being produced. So we have nuclear fusion going on in there, and all of these little photons are trying to get out. The next part is the radiative zone, and this is where the photons are moving around, making their way towards the edge of the sun. So this is where they're being absorbed, they're being re-emitted, they're bouncing off of each other. And then this last outer line represents the photosphere. This is the outer edge of the sun and the place where the photons will leave the sun into open space. So in Classroom, there's a link to a website called random.org. And what you want to do is you want to choose 2 virtual dice for this activity. So you're going to start in the core, and then you're going to roll the dice. So this first roll is 12. So then you're going to look at the diagram right next to it to see which direction that you're going to move. Now notice that odd numbers do not move at all. So they do count toward the total number of rolls, but they don't count towards moving. So it is also possible to have a roll cause you to retrace your steps. So sometimes you go backwards. So since the first roll was 12, the photon is going to move up and to the left. Okay. So we're going to start there in the center, and we're going to draw a line up and to the left. Then we're going to roll again. Okay, this roll is 5. 5 is an odd number, so it will not move, but we will count it in the total number of rolls. So now we have 2 total rolls, but we've only moved once. So the next roll is 9. So again, we stay put. The fourth roll is 8. This will cause us to move our photon down and to the left. And then we're just going to keep rolling. So if we have a 6, we're going to move down and to the right. We have 8, we're going to move down and to the left. 3, we stay put. 8, we move down and to the left. And once we get to this outer layer, this means that we have exited the radiative zone. So if we look at our random walk through here, we have a real zigzag pattern from the core of the sun to the outside. And our total number of rolls is 8. So your assignment now is to complete your own little sun. So do a random walk for your sun. And then there are 2 more on the next page for a couple stars that are a little bit bigger than our sun. So what we need at the end of this is the total number of rolls that it takes for you to get out of the small one, out of the medium one, and out of the large one. So pause here and take a little bit and go ahead and do that. So now that you have modeled that random walk, we have that gamma radiation being produced by nuclear fusion in the core of the sun. We have those photons spending all of that time bouncing around in the radiative zone before they exit out into the convection zone. Now, the convection zone is that kind of outer layer of the sun. And here we kind of have another little camping out of our photons as they kind of move through here. Now, remember from first try that convection is when matter rises or sinks, right? So warm things rise and cool things sink. So the same thing happens inside that outer layer of the sun. We have convection going on. So those particles are heating up and they are rising, and that takes energy to the surface. And so then they're going to cool and come back down. And so we kind of get this cycling of these particles through convection at the surface of the sun. And it kind of looks like if you've ever watched water boiling, it looks very similar to that. And we get these really bright blobs on the photosphere where that hot gas is reaching the surface. So when we look at a sun with a telescope, don't ever do this, by the way, without a filter. When we look at the sun through a telescope, we can see these blobs at the surface, and these are called convection cells. So that's kind of the end of the sun. Those are the different parts of the sun and the different layers of the sun. It's not terribly complicated. There's just a lot of things going on there.